Hi, this is John. This video is about composite lamination, particularly flat parts under pressure. I'm going to demonstrate this using a food saver because it's a great intro method to vacuum bagging. Of course, the techniques that I'm going to be showing can be used with a vacuum pump and bags or a veneer press, whatever you have access to. The food saver is a great little unit. It's made for preserving food for long-term freezing storage. It does a pretty good job of evacuating the air, and it's quite sufficient for most of our purposes. The part we're going to make is a Nike fin. Now this is a popular model, and it's got interesting fins. They're originally made out of bent sheet metal, so they have a complex profile. They taper from root to tip, getting thinner at the tip. They also have tapers from roughly a third of the way to the leading edge and a third of the way to the trailing edge. So it's got a compound taper on both sides, and it's not the kind of thing that you can reproduce well with a flat fin. We're actually going to do two laminations, a flat lamination and a compound lamination over the top of the fin after we have all the tapers. The flat lamination is on the core. For the core, I've chosen 1/16 inch plywood. This is aircraft plywood. You can get it at most hobby shops, made by Midwest. Despite the fact that it's very thin, it's still got 3 plies. It's strong, stiff, flat, no voids. It's great material. It's easy to cut. I've cut out the shape of the core. This is the area that will be exposed, that will have the built-up balsa. This is the area for the tip, for the through the wall tab. This plywood is probably good enough as it is, but just to make sure that we have a stiff core with no warps, I'm going to laminate it with carbon fiber. Carbon fiber's property of interest here is stiffness. If we put a layer of carbon fiber on both sides of this fin, it's going to be stiff. It won't flutter, it won't bend. And in case there are any warps or bows in the plywood, we're going to use a flat lamination with a baseboard, and that way we'll make sure that this thing is absolutely flat while it's curing, and then once, of course, the epoxy is cured, it'll be held in that position. So our first lamination is a flat lamination, and by that I mean we're going to do it on a baseboard so that we can use the baseboard to make sure that the part ends up flat. What will happen is the vacuum will draw down, pull everything flush against this plate or baseboard. I'm using 1/2 inch acrylic covered with non-porous Teflon release film just to protect it from epoxy. We're going to use carbon fiber for the lamination, one 5.7 ounce layer on each side. The other pieces here, this is release and breather. We put the release immediately on top of our cloth after it's wet out. And what that does is when the vacuum bag pulls everything down, the excess epoxy is forced through this release. This is porous Teflon release film, so the epoxy can actually migrate through. Any excess epoxy that isn't embedded in the matrix of the carbon fiber will be pulled out. And this is breather. The excess epoxy will be pulled out into the breather so that we can easily remove it. And the breather won't stick because of the release film. So this was saturated with epoxy, placed on the part, release film goes on top, breather goes on top, vacuum bag squeezes it down, excess epoxy migrates through the release into the breather and is pulled away from the material. And always when working with composites, before you mix epoxy, make sure you're ready to go. In this case, I have my part ready to laminate, my cloth, release breather cut, baseboard ready, surface covered, so epoxy drips won't ruin my table, and prepared the bag. For the food saver, I like to double seal it, so I've run 2 seals across. The bag needs to be extra long because you need space to seal, plus you don't want to be super tight quarters. So extra long bag, double sealed. Now I'm ready for the epoxy. Okay, go time. Epoxy mixed. Of course, for this purpose, we want a thin laminating epoxy. A brush. I like to use these cheap chip brushes. You can buy a case of them relatively inexpensively and use them and throw them away. One thing with the cheap brushes is your bristles sometimes will pull out, so it's good to make sure that you don't have any loose bristles. And when you're painting, make sure that you keep an eye out for any strays. So I like to wet out the part before I cover it, just to make sure it's not starved. So we'll paint epoxy. Quick check, make sure there's no bristles from the brush. There's one. Pull that off. And then we're ready. Take our reinforcement, carbon fiber, place it on. Make sure that it overlaps the part on all sides. And if we press the carbon fiber down a little bit, then we'll see the outline of the part underneath. Just that a little bit. Luckily, carbon fiber is really nice to work with. So you can pick it up and peel it, unlike fiberglass if you need to adjust a little bit. You can also turn it upside down. Place it on so it's square. It's fiddling, but it's okay. Our first layer of epoxy gave it something to attach to. So now we paint out. And this time we want to make sure that we saturate the carbon fiber. We don't really need to go much past the edge of the fin, but we want to make sure all the part where the core and the fabric touch is thoroughly wet out. This is one respect where fiberglass is easier to work with because you can see when it's wet out, it goes transparent. With carbon fiber, you need to pretty much put on extra and depend on vacuum bagging to pull off the extra resin. You can feel it a bit because the brush moves more easily when it's been wet out than when it's dry. But, yeah, another stray bristle. And you can feel when you're just dragging through epoxy that's fully saturated. So that's one side. We take our release cloth, place it on top. See how the epoxy is already starting to come through? Take a piece of breather to protect ourselves. Keep our hands clean as we go. Keep our surface clean. And one side's done. Now we do exactly the same thing on the second side. Okay. Wet the core. Place our second side with lamination. Press it down so we find the edges of the fin. And complete the wet out of the reinforcement. With such a small fin, this goes quickly and easily, but even if you're doing a larger fin, it just isn't that hard as long as you prepared everything in advance. If you're working with a good epoxy, you'll have plenty of pot life. You won't be racing. Again, you can feel when it's fully wet out because the brush moves easily and you can see it saturate the fabric. Okay. Now, put on our second piece of release. Make sure that's nice and adhered, smooth, no wrinkles. And second piece of breather. So now the part is ready to go into the bag. I'm going to clean up any miscellaneous drips. Try to keep everything clean from this point on. If we had other parts to do, we could set this aside and move on. In this case, we're just going to do this one. Okay, so we have our epoxy on, our release and breather on. It's a nice little package. So now we're ready to put it in the food saver. We're going to use the baseboard so that this thing ends up flat. It's easier when you're sliding in the bag if everything is taped together. So we'll run a little tape over the parts, attach it to the baseboard. Then all we do, slide the whole thing into the food saver, and we're ready to go. Now the way the food saver works is it dispenses this bag in a roll, so you cut off the length you need, and then you put the food in it, and it draws a vacuum, and then this band does a heat seal. So the way we use it is we place the excess end into the food saver like this cavity where the vacuum will be drawn, and then this area at the end of the vacuuming will be where it seals. Close it. Press the on button. Now it's drawing the vacuum. See how it's sucking everything down? You can hold this to get a little more vacuum. And then once it pulls the desired vacuum, it does the seal. You can hear the vacuum release, and we have our part vacuum bagged. I like to do an extra seal. So you can place it on the sealing bar again, some of the leftover part. Hit the manual seal button. Do a second seal. There we have it. So our part's in the bag. You can see it sucked down nice and tight. The release and the breather are pushed down. The whole part is flattened against the board. So the resulting part will be totally flat, no warps. And then we let this fully cure. Okay, while the core is drying, let's start working on the raised profiles. Balsa is a great material to work with. It's light, easily obtained, and easily worked. For each side, we're going to need to build the built-up profile. So we're going to use basically model airplane techniques of working on the board. The balsa I have isn't quite wide enough, so we need to put it together in blocks. Of course, balsa bonds easily with white glue, but it's quicker to do it with CA. A few drops of CA at the joints. We'll wick in. Okay, once we have our block, we want to make our taper. I chose the thickness of the balsa so that the root edge stays full thickness, but I need to taper it down to about 8/100ths of an inch on the edge. So I find it easy to give myself a guide. Balsa is very easy to sand, so you could probably do without a guide, but we'll go ahead and do a jig. So I've got a little jig, harder materials on both ends. This is all just held down with double stick tape. Great stuff. We have coarse sandpaper on a sanding block, and we're just going to start sanding it. By putting most of the pressure on the side that I want to be thinner, I can get consistent taper by sanding down to my guide strip at the tip edge. And quite quickly, we work down to a point where we have the taper. At this point, we've hit the bottom guide. We can take our piece out and see how we have a nice taper. So now we come back to our building board to trim our taper profiles. The model airplane techniques of building on a board means you use a full-size plan to measure everything too, so it's nice and easy. So in this case, we place our part on the board to get our dimensions. And simply cut off the parts we don't need. Nice sharp X-Acto knife makes quick work of balsa. Okay, I've cut out the shape of the fin and marked the top of the tapers forward and aft. And now the leading and trailing edge profiles. Once again, I'm going to use aluminum tape to give myself a little bit harder edge to sand to. I'm just going to do this freehand because this is a very small area and it's now double compound, so it's a little more difficult to jig. Here, I'm just going to sand and just basically do it by eye. And because the balsa sands so easily, I'm just going to be able to feel as I go down and produce the taper. And as you get towards the end, just go slowly and carefully. So the goal is to get a taper even along the whole front, down to nothing. And once we sanded the other side, we have half of our profile. The guidelines help us make sure that we don't sand too far into this and get a nice crisp profile. We can clean it up a little with some finer sandpaper, since the grooves from the coarse sandpaper are rough. But we're going to cover this with another layer of reinforcement. So this isn't critical. Just get it nice and smooth. And there we have our half profile. Okay, so we let our core cure overnight. The reason that I wanted it to let this fully cure is that way if there are any warps or bows in the core, the epoxy will be fully cured and the carbon fiber will keep it flat. So now we open our food saver bag. You can reuse these bags once or twice, so I cut off as little as possible. And here it starts to release. I would release the vacuum. So now when you do vacuum bagging, the pieces seem stuck together, but because of the release, you can peel the breather away. And you'll notice there's an epoxy shape in the breather where the epoxy was sucked through. The release comes off and can in fact be reused. have our part. Because this is fully cured, cutting off the excess reinforcement is a little tricky, but it's not hard as long as we take our time. Get an X-Acto knife with a fresh blade. Make sure you have a guide to protect the core material. Run a few cuts through until you get to the baseboard. Then it peels away. Do that all the way around, and our part is removed. Now it's time for our second lamination. We have our core produced by our first lamination. This is already a great thin. It's thin, stiff, light, and strong. However, we're going to laminate the Nike profile pieces that we made to give it the prototypical shape. What I've done to prepare the core is I've lightly sanded it, marked the edge of the through the wall tab, and covered that with tape because we don't want to get fiberglass or reinforcement on the tab. We want to keep the tab clean so we can bond well. Now we're ready to go ahead, mount the profile, and skin it. And we're ready to go. So the first step is we're going to bond the profiles to the cores. You don't need an excessive amount of epoxy. It will wake up into the balsa, but we don't want to add unnecessary weight that doesn't add strength. We do want to make sure we get to the edges though, so that we have a good bond all the way along the surface. Now we have our core wet out. Sure the surface is clean. Take one of our pieces, lay it on. Shoot square. That already sticks reasonably well, but I'm going to add a few drops of CA to make sure it doesn't move around. Careful not to CA the tape. Okay. If there's any excess CA, you want to wipe it off because it may interfere with the epoxy adhesion. But you also don't want the profile to move around. Okay, one side. And similarly, we attach the second side profile, make sure it's tacked down with CA, and now we're ready to laminate. Again, same deal as before. We're going to wet out the surface to be laminated, apply our lamination, and then make sure the cloth is fully wet out. Now the materials we're working with are very easy. Balsa and cloth are easy to see as they wet out. So we painted a layer of epoxy across the entire balsa, and now we'll lay on our reinforcement cloth. Again, you can see how easy it is to wet out fiberglass. See how you can already tell it's going transparent? All we need to do is make sure it's entirely wet out. Again, We don't want to get sloppy, but a little excess epoxy is okay, so it will be pulled out in the process of vacuum bagging. Once we're satisfied that the cloth is wet out thoroughly, a bit past the edges, again, same drill, release fabric, breather, turn it over, same deal on the second side. When we have both sides wet out, covered with release and breather, package is again ready to go into the bag. It's easier if things don't move around, particularly the breather tends to slide around. So I like to tape it up, make a neat little package so it's cleaner to insert into the bag. Now, what I want to do is, unlike the core, I want to take this out of the bag and trim the excess when the epoxy is at the leather stage. But how do you tell whether it's at the leather stage inside the bag? What I like to do is take a little scrap of fiberglass, paint it with a little epoxy, and leave it outside the bag. So here is my little test piece. So when this reaches the leather stage, I'll know the stuff in the bag is also at the leather stage. Again, food savoring. Make sure the bag end droops into the vacuum cavity slightly. Close. Turn it on. Watch it start to draw the vacuum. Again, no baseboard, so it's going to vacuum pressure from both sides of an irregular surface. We get our first seal with still the vacuum applied. Notice how the bag's been pulled down all the way around, so the breather is in tight contact to pull out the excess epoxy. Again, I like to make a second seal just to make sure. Although this thing is pretty good with just one seal. And there we go. Second reinforcement applied. Okay, so checking on the progress. The leather stage means that the epoxy is no longer sticky and that it's partially cured to the point where it's thick and not going to move around. So this isn't completely cured, it's not stiff, but it's definitely thick enough. Okay, and we're ready to remove our part the second time. And because we took it out of the leather stage, it's easier to cut through. You just run the knife along the edge. And then, so once we trim the excess fiberglass off, we can let the thing cure. Once it fully cures, it'll be ready to use. It can be mounted as is, painted. It could be mounted and then tip-to-tip fiberglass reinforcement. But as a fin itself, it's incredibly stiff and strong, and it has our Nike profile, the compound taper from root to tip, forward and aft. Prototypical profile.